Right, today in class we're going to talk about attributes and their measures. So for each quantity we're going to choose one or more appropriate units of measurement. And so for 7 and 8 we're going to come up with things that could be measured by this. So when we talk about perimeter of a parking lot, we're talking about how can we measure that? Well, perimeter is the distance around something. So that's like a fence or something that can be measured in feet. It could also be measured in meters. The volume of a semi-truck. Volume is talking about multiplying three numbers together. Therefore, when I'm talking about volume, it should be something that's cubic. So of these, I have cubic yards and cubic kilometers. Nothing else can be measured that way, so I'm going to use cubic yards. Volume of semi-truck. For surface area of a refrigerator, we're talking about area, and we're talking about the surface of each side of the refrigerator. So for that, we can measure that in square feet or square inches. For the length of an eyelash is really small, so we're just talking about the length of it, which is one-dimensional. We're going to use millimeters. The area of a state, remember area talks about multiplying two numbers together, therefore you should have square something. So for area of a state, square miles. And then the volume of an ocean, cubic kilometers. Makes sense. Something that I can measure in miles is I measure a road, right? So you're driving on the road, it tells you there's 60 miles until your destination. And then for something in cubic meters, what I can do is, a swimming pool. If I wanted to, a swimming pool for that. So this one we're just talking about looking at quantities and then how they would be measured using feet, square feet, cubic yards. So it's understanding that perimeter is one-dimensional, area is two-dimensional, and volume is three-dimensional. All right, then the next thing on the side is you're going to get 16 cubes and you're going to build two different shapes. So I'm going to go ahead and build two different shapes. So this is one shape, right? That's using 8 cubes. It's one shape that I'm going to use. Then the other shape I'm going to make it's going to look like this. So the reason for this is I wanted two different shapes, and then the first thing it asked me to do is give them a name. So I'm going to call this shape over here, I'm going to call this Allen's cube. And this shape over here, what I'm going to name this is Allen's rectangular prism. Now, the second thing it asked us to do, so I labeled them Allen's cube, Allen's rectangular prism. It says determine the volume. Volume is asking how many cubes there are total in this, right? So to find the volume, we have a couple measurements. We're going to use 3 measurements. So this is a 2 by 2 by 2, right? So there's 2 at the bottom, right, to measure the front of that. Then there's a height of 2, and there's a width of 2 that goes back. So volume equals length times width times height, especially for a cube or a rectangular prism. So I have the numbers 2, 2, and 2. When I do that, 2 times 2 is 4, and then times 2 is 8. Now my question to you is that's 8 cubic units. My question to you is, we started out with 16, of these, but we only used 8 in this. So that's where that 8 comes from. Is the fact that we only used 8 of these snap cubes to make this cube that we see here. And then the surface area is going to be different. So the surface area, right, is the area of each face. So I have 1, 2, 3, 4. But remember, in a cube, all the faces are identical, right? So this is 4, 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 and this is 4. And we should understand that a cube has 6 faces. So if every side is 4, 4 times 6 would give us 24 square units for this cube here. For the rectangular prism over here, to find the volume, what we're going to do is we're going to understand that this front side is 4, the height is 2, and it goes back 1. So that's volume equals length times width times height. We get a 4 times 2 times 1, or vice versa, 4 times 1 times 2, right? Either way that we look at that is going to work out. That's going to give us 8 cubic units as well. All right, the surface area of this is going to be a little different than the cube. So I'm looking at this face right here. On the front, I have 1, 2, 3, 4, 5, 6, 7, 8 of these. And so the front and the back of this should be exactly the same. So I'm going to do 8 times 2, which gives me 16. That's part of my surface area, right? Now I'm going to look at the top of this. The top of this has 1, 2, 3, 4. And so the bottom should be identical to that, 1, 2, 3, 4. So I'm going to do 4 times 2, which gives me 8. And then the sides of this, right, the sides, I have 2 here and then 2 here. So I'm going to do 2 times 2, which gives me 4, and I'm going to add those together. So 16 and 8 make 24, plus 4 is 28 square units. So even though both of these shapes, or both of these polyhedra, are made of 8 snap cubes, they have different surface areas. So they're made of the same volume, so they have the same volume, but their surface areas are different based on the fact that we spread some out. So some of these cubes are hidden, right? So if I stack some on top of each other, some of them are hidden from the side. But in this one, I elongate them, you can see more of the cubes because there's only sort of this, there's none of the cubes that are hidden or covered. So that's why you get a little bit more square units there.